This is a look at Edwin Hubble's galactic observations. Could you please tell us your name and tell us about your project?
Well, my name is Dalton Maloney, and my colleague Edwin Hubble's galactic observations prove that our universe is ever expanding. And he did this by utilizing Henrietta Swan's discovery that Cepheid variables follow a period luminosity relationship. And Hubble, along with his group of astronomers and mathematicians, which included me, were able to determine the distance between the Cepheid variables and our universe. And by the way, just in case you didn't know, a Cepheid variable is just essentially a star that pulsates light.
Okay. What were you guys trying to find or do?
Well, we were observing and taking photographs of stars that were thought to be in the Andromeda Nebula, and that Andromeda Nebula is within the Milky Way. And the most vital component that was used for this experiment was the 100-inch Hooker telescope, which was actually the largest telescope at the time.
Where did the project or experiment occur?
We actually conducted the studies at Mount Wilson Observatory, which is located in Los Angeles, California, and these studies were performed between 1923 and 1929.
What were some other significant events that were happening around the world at this time?
Well, Albert Einstein published his theory of relativity in 1905, which is pretty close to this. And within his finding, Einstein observed that stars did not appear to be moving closer or further away from each other. And because of this, he added a factor to the theory that made the universe motionless, which we, kind of proved a little bit wrong, but, whatever. And other events that happened outside the scientific community included World War I, which Edwin Hubble was actually a part of. And he was believed to be fighting in France at the time. Despite the fact that he was in war, he didn't let the war tear him away from his passion of astronomy. And I also heard a legend that he taught soldiers how to march at night by guiding themselves with stars.
Interesting. Who else was involved in your project?
Well, Edwin Hubble was actually hired on at Mount Wilson Observatory by George Ellery Hale. However, Hale retired right around the time that Hubble observed the first Cepheid variable, which he observed in 1923, and he later named VAR.
What was your role in the project?
My role was actually kind of minuscule, but all I did was maintain equipment that was found within the lab, and if anybody needed help, I was there to help out. However, my biggest responsibility was keeping the Hooker telescope up and running in good shape, and since it was the largest and most expensive telescope at the time, that was a very, very hard task to do.
Okay. What impact did your project have on the physics community?
Well, Hubble's findings originally stated that there was more to the universe than just our Milky Way galaxy. His original findings stated that there were other small universes, which he referred to as island universes, and they were actually very similar to the Milky Way. A few years after this discovery, Hubble made an even more incredible discovery that our universe was actually not static and that it is expanding at an incredible rate. By observing other cosmos through a telescope, he recognized that they all seem to have a red spectrum to them. This is actually caused by redshift, and redshift is defined as a shift toward longer wavelengths of the spectral lines emitted by a celestial object, and that is caused by the object moving away from Earth. And this discovery led to the creation of Hubble's law, which proved that the universe was actually expanding at an incredible rate. And although Hubble's law has been improved since it was originally founded, it still affects the physics community today, and it's still one of the most important things that we use.
Okay, and final question. How have Hubble's findings helped in the determination of the age of our universe?
Well, that's kind of an interesting topic, but it's like whenever you're watching a movie and you decide you want some popcorn. So you don't pause the movie and you go and make your popcorn, and you come back and you catch the tail end of an explosion. Now you want to see when the explosion first started and what it looked like and how long it lasted. So because you can just rewind it, you can figure out when all that stuff happened. And Hubble's findings is basically the same thing. We know that the universe is constantly expanding, so we can just rewind it back to the beginning and we can find out exactly how old the universe is. And by doing this, by using this exact method, scientists and physicists alike have calculated that the universe is about 14 billion years old. Do you have any other questions for me?
No, that is it. Thank you for meeting with us.
Thank you.